This is about cluster analysis. So suppose that you have a lot of data, like over 4,000 wines, and you need to cluster them based on their chemical properties. And we face such situations quite often. So cluster analysis is developed for that purpose. And roughly, there are 4 different kinds of clustering the data sets. Firstly, you cluster nearly positioned cases. So you group them and then make a bigger group, bigger group, bigger group. So you, based on the distances from neighbors, you cluster them into small, like a small village and a city and province like that. So in a hierarchical order. And second one is you start from random initial points, and from the random initial points, they count nearest items, and then eventually they meet a certain boundaries. And usually they pursue the equal number of each partition. So you can artificially assign the number of partitions in this case, or you can optimize the number so that each cluster has similar number of cases, or you can control the numbers and the size of the partitions. Or when you know the theoretical center points, then based on the distributions, you can cluster the items. Or you base on the density membership. So based on where the density are mostly found, then you can cluster them. So based on the set of characteristics among the observations, such as the evaluation scores or the properties of each individual observations, you can have clustering analysis. Okay. So firstly, I'm going to introduce you the hierarchical cluster analysis and the dendrogram. Suppose that you have 6 kinds of wines here, and based on their chemical properties, wine B and wine C are quite similar to each other, and D and E are quite similar to each other. And A wine is so unique, so it has a quite large distance from the rest of them. And based on this observation, you can draw this tree-structured diagram, and this is called the dendrogram. So the hierarchical cluster analysis, if there are too many observations, you can figure out there are too many leaves and branches. So dendrogram really doesn't give you any insights. So in my personal opinion, when the observations are not that many, then it's more useful. And the hierarchical cluster analysis is useful for drawing the dendrogram. So this is a tree diagram and frequently used to illustrate the arrangement of the clusters produced by the hierarchical clustering. So you can explicitly find out where each instance is clustered, and then with whom, and eventually they become one group. Okay, then how can we measure the similarity between the instances numerically? So let me introduce you how to quantify the similarity between the instances. Suppose you have 4 different products and they were assessed in terms of freshness or flamboyance and sensuousness, and each product obtained these kind of scores. All right, so obviously this calculator is quite pretty different from this chair. So this kind of characteristics can be briefly observed, but we want to quantify them, right? So we estimate the Euclidean distance with regard to each measurement, which means, for example, the Euclidean distance between this typewriter and this chair is that in terms of freshness, the difference between this score and this score corresponds to here, and you scale it, and you scale also the other difference, and you scale the other difference. And then eventually you add them all, and you can compute the square root of this sum, which is exactly the procedure of calculating the Euclidean distance. Okay, if you have more adjectives here, then you do furthermore. Okay, right. So eventually you have the values to be filled in these empty cells. And the directional information is here ignored. So only the half of the rectangular will be actual square will be filled. And the between itself is, of course, the distance is 0. All right. So you complete this square matrix, and this is called the proximity matrix. The internal distance pairwisely estimated. Okay, so if the chemical properties between Y and B and Y and C are similar, then maybe in this proximity matrix, the estimated Euclidean distance between B and C should be very near, right? Very small number. So, however, when the A is quite different from the other ones, then the Euclidean distance between A and B, A and C should be much farther than the rest of the combinations. All right, so based on the assessments of a set of characteristics, observations have internal distances from each other. The Euclidean distance is the most well-known technique to measure the between distances. Depending on the method, you can apply the squared Euclidean distance to exaggerate the distances. All right, and this proximity matrix is aggregating the distances, and it displays the conceptual distance between observations. All right, so in making dendrogram or hierarchical analysis, we can apply in SPSS different methods. And in social science, the centroid method and ward method or ward 2 methods are the most frequently used. And because the Euclidean distance is resulted in any cases, so the cluster analysis is not getting screened through the statistical significance. So some say that this is not statistics. Maybe it's not, but it's very much useful because it always gives us the answer, right? So if you use a single, then out of same data, you obtain this dendrogram. If you use a complete, then you obtain similar but slightly different, right? So in this way, you can derive different dendrograms depending on the method you have chosen. So based on the dendrogram, you can apply the slice moment. So if you have applied the slice at here, then we have how many clusters? Yes, 3. One very big cluster, and second is maybe too much, and the third one is too simple compared to the rest of them. I think the selection was a kind of a bias to decorative or more extravagant style. I think it's my personal bias. Anyway, we can observe this kind of tendency that just looking at this, oh, this product has been quite differently assessed compared with the rest of the products. So size-wise, Group 1 is the biggest, and Group 2 and Group 3 are containing only one item. Then maybe you can think like, maybe you better exclude these 2 items so that you only have this branch, and this branch looks like kind of balanced left and right or something like that. So maybe colorful and monotonic and metallic or something like that. So you can assign better the properties. I mean, I'm talking about the designer's perspective. I am in SPSS, and I'm going to demonstrate you how to do this hierarchical cluster analysis. And suppose that we have 18 observations, and 12 of them are about cars, and the rest of them are about the voice types. And the cars and voices were assessed using the same adjectives, from sensitive to friendly. Okay. So my intention is to see whether the cards are clustered as cards and voices are voices, or some cards and some voices have so similar in terms of the emotional appeal, so they are their Euclidean distance is nearer than some completely different cards. So let's visualize the results and analyze them. Hierarchical cluster. And based on the adjectives and maybe number is label. Okay, and the cluster analysis is intending clustering the cases, but technically you can cluster variables too. But if we want to cluster variables, then my recommendation is to perform the factor analysis, which is statistics. Okay. All right. And plots dendrogram. Okay. Oh, by the way, in the method, right, you can get the proximity matrix here too, and the plots dendrogram. Okay, and methods. All right. So clustering method, wired method I'm gonna use. All right. But you can try out different methods too. Okay. So the cluster, the title, 18 has been observed, and the proximity matrix is it's just symmetrical. But so you can look at only the half of the square. So this is the proximity matrix based on the estimation method. I think we assigned the Euclidean distance. All right. So among the voice types, car 1 is most similar with voice type 2, for example. Right. So this kind of relationship is slightly identified, and right, and eventually the dendrogram. So roughly these 12 cards and 6 type of voices were clustered into 2 big groups, and in each group voices and cards are clustered together, which is quite interesting, right? And then from the first group we can divide 1 and 2, right? So you can draw different dendrogram if you use different method. So using wired, we obtained this dendrogram, and you can slice it depending on your research interest. All right, and the second one among the 4 is that the partitional cluster analysis. And before this machine learning driven approaches in AI domain became dominating the entire academic world, the K-means clustering has been treated as one of the clustering method in cluster analysis, and cluster analysis was one of the statistical courses in application of statistics. But since the machine learning driven approaches are very much popular in across the different domains, people are starting to sort this K-means clustering as a kind of unsupervised machine learning algorithm. So in SPSS, you can easily perform this K-means clustering just like ANOVA or t-test. And what it does is that you assign the number of clusters, and you let SPSS compute what kind of instances belong to which clusters. So you don't teach the algorithm where should be the initial point. So it's not supervised, it's unsupervised, because it randomly assigned the initial points. Manually you can assign, but in principle it has been developed that you don't have to assign the initial points. But regression analysis kind of thing is you should train the data, right? Input is that, output is that. Input is this, output is that. After repeating this, learning this relationship, the regression equation is derived. But in K-means clustering, you don't need to do anything. You just bring all the data and you assign the number of clusters, and it gives you the results. I'm in SPSS, and I am having a lot of wines here, and each has different properties from fixed acidity to quality. So based on their chemical properties, maybe I don't include the quality. Based on their chemical properties, I am going to sort them into several groups using K-means analysis. So clicking analyze and classify K-means cluster. Okay, so based on their chemical properties up to alcohol, and number of clusters 5. Okay, save, and I want to have the membership as a result and the distance from the cluster center. Okay, right. So I gave the 5 clusters, and here is where each wine or which group the wine belongs to. So first wine, white, belongs to group 2, and second also belongs to 2, but third one belongs to 5, right? So in output window, we see that there were 5 clusters, but in cluster 4, there is only 1 wine out of 6,000, almost 500 wines. So in this case, I would exclude this 1 wine and then compute the clustering analysis again. So in this way, you can randomly assign the number of clusters, but you have to check whether the proportionally or size-wise, each cluster has the equivalent number as you intended. And in the meantime, there are alternatives of K-means clustering. So in K-means clustering, the single observation belongs to one of the clusters. But for example, the fuzzy C-means is allowing single observations into more than one memberships, so proportionally belonging to different memberships. And if your research question is pursuing that kind of proportional membership, then maybe fuzzy C-means is more appropriate. And then, for example, the image segmentation in computer vision area, fuzzy C-means is often used. But in sorting out your consumer groups or grouping your products, you don't divide one product into 2, right? Then maybe K-means clustering is more proper for your research purpose.